Okay, today we are going to learn mood sorting algorithm part 2. If you haven't seen part 1 in our channel, go and check it out. It will helpful to you to understand this in better way. Okay, this mood sorting algorithm part 2 is to find the majority element which are greater than n by 3 times. Okay, before going to the algorithm, just we will find how many possible number of elements will be there in an to which are n by 3 times in an array. Okay, let's take length of 7. 1, 2, 3, 4, 5, 6, 7. 7 is our length. Now, minimum number of possible is 7 by 3, right? 7 by 3 means it is 2. So, minimum number will be always 3 for this array of size. So, if an element which is greater than or equal to 3 of frequency, then we can say we can include it in our answer. Right? Let's take an element as x, x, x. Okay. Next element as y, y, y. And next element as z. Okay. From this observation, you can conclude that you can arrange any number of elements in these 7 places. The majority means the maximum number of elements can be the answer is 2. Right? What are the how many minimum number of elements can be there? It is 0. Because if you keep A, B, C, D, E, F, G, then there is no element which has the frequency of greater than n by 3 times in this array. So minimum number will be 0 and maximum will be 2. Right? Now let's see the algorithm. Let's go into let's go. We'll take candidate. So since the majority will be 2, we'll take candidate 1. It should be some value which is not present in the array. We'll take something. Okay. And candidate 2 will be same another value which should not be in this array. Okay. Now we have to take the count. 1 is equal to 0. Count 2 is equal to 0. Now basic algorithm is we will check by element in our array. If the count 1 is 0, then we will we'll take an example 1 comma 1 comma 2 comma 2 comma 3 comma 2 comma 1. 1 2 3 4 5 6 7. Okay. No. If here it is our element, right? This element and this candidate should be if the count is 0, count 1 is 0, then we have to make this candidate as this element as 1 and we have to increase the count as 1. Okay. Next we will go to here. We'll check whether this element and this candidate 1 both are same. Yes, both are same, so we will add a count to. Okay. Now we'll check here. This element and this candidate both are same? No. Then we have to check here as well. These both are same. And if it is count 0, then definitely we have to add it, right? And it becomes 1. Okay. Now, this candidate and this candidate both are same? No. Whether these two? Yes. So we have to increase count by 1. Okay. Now here. Is candidate 1 is same as an element as 3? No. Is candidate 2 same as 3? No. So then we have to decrease the count both by 1. 1 and 1. Now, increase and now check the next element whether this is equal to the candidate 1. No. Whether this is equal to 2. Yes, we have to increase the candidate by 2. Now let's check here whether this is equal to candidate 1. Yes, we have to increase by 1 by 2. Okay. Now look, we got two elements. The both are 1 and 2. According to this array, both are the answer is perfect, correct. But now look here for this array 1 comma 2 comma 3 comma 4. Candidate will be something, let's take integer minimum value and count 1 will be 0 and candidate will be integers minimum value here 2 here 1 and count 1 will be 0. Now at this element with the count 1 is 0, so we have to make candidate 1 as 1 and count as 1. Now whether this 2 is equal to candidate 1, no. Whether this 2 is equal to candidate 2, no. We'll check it. Count 1 is 0. Since there is no element here, we have to add count 2 and we have to increase the count 2 by 1. Now we'll go here. Whether 3 is equal to count 1, candidate 1, and whether 3 is equal to candidate 2, both are no. So we have to decrease by 0. Okay, now we'll check. We'll check 4. Look here, 4. Count 1 is 0. So we have to change this and we have to check again count 2 as well because there is a chance that here can be a 4 is included, right? So we have to check count 2 as well. Whether it is count 2 is 4, no. So we have to increase count by 1 and we have to make this count as 4. Now look here, we got candidates as 4 comma 2. But in this array, these 4 comma 2 is not repeated by n by 3 times. So this is wrong answer. We got the wrong answer. So after getting the candidates, we have to check manually whether these candidates are n by greater than n by 3 times. Okay, let's write pseudocode. Now we'll take int candidate 1 as integer min value and candidate 2 as same integer min and count 1 is 0 and count 2 is also 0. Now for int I in nums, right? If count is 1 is 0 and this I is not equal to candidate 2, then count will be 1, count 1 will be 1 and candidate 1 will be this I, right? Now else if count 2 is equal to 0 and I is not equal to candidate 1, then count 2 will be 1 and candidate 1 2 will be I. Okay. Next, else if candidate 1 is equal to I, we have to increase the count to 1 plus plus, right? And else if candidate 2 is equal to I, count 2 plus plus. Else we have to decrease count 1 minus minus and count 2 minus minus, right? Hmm. Now we have to check whether the got answers are like what we got candidate 1 and candidate both as our required answers or not. How can we check? We'll make count 1 and count 2 as 0 and the minimum value will be n divided by 3 plus 1, right? The minimum number of frequencies should a candidate 1 and candidate should have. Now we'll use for loop again in I to nums. If I is equal to candidate 1, then count 1 plus plus. If I is equal to candidate 2, count 2 plus plus. Here, if count 1 is greater than or equal to meaning, then we have to add in answer. If count 2 is greater than or equal to meaning, then we have to add it in answer. Right? We have to, at last, we have to return ends. This is the base pseudocode for our algorithm. Now let's try the question in our LeetCode. Okay, let's solve this question. List integer n is equal to new array list. Candidate 1 is equal to integer dot means underscore values, comma candidate 2 is equal to underscore values. On 1 is equal to 0. On 2 equal to 0. Okay. Now for I nums, if count 1 is equal to 0 and candidate 2 is not equal to I. Then we have to make count plus plus or count is equal to 1 and candidate 1 should be is equal to I. Else if count 2 is equal to 0 and candidate 1 is not equal to I, then count 2 plus plus and here count 1, sorry, minus 2. And candidate 2 should equal to I. Okay. Else if both are wrong, so then we have to find candidate 1 is equal to I, then count 1 plus plus. Else if candidate 2 is equal to I, count 2 plus plus. Else candidate 1 is equal count 1 minus minus, count 2 minus minus. Now here we have to check the manual, right? So let's check mini value as length divided by 3, 3 plus 100. The minimum should be this. And we have to make count 1 should 1 as 0 and count 2 as well 0. Now, for int I announce if candidate 1 is equal to I, count 1 plus plus. If candidate 2 is equal to I, count 2 plus plus. Right? If count 1 is greater than or equal to mini, ns dot add candidate 1. If count 2 is greater than or equal to mini, ns dot add candidate 2. Now here we have to return ns. Oh, sorry, here we have to keep this. Okay, let's run it. Yeah, done.